Complete Ionic and Net Ionic Equations, The Easy Guide to the Hard Stuff, by me, Kelsinor. Alright, here's an example problem. You can take any ordinary chemical equation, most likely in the form of a word problem. For example, when aqueous solutions of sodium phosphate and calcium chloride are mixed together in insoluble white solid forms. How the heck do we handle this one? Let's look at it and find key information. Step 1. Analyze the problem. Well, first of all, how would we write this problem? Well, we all know that these symbols stand for what I've put on here, and that results in the beginning of the skeleton equation, which is Na3PO4 aqueous plus CaCl aqueous, which are the reactants. If you look at a solubility chart, it states that calcium and sodium are soluble, which replace each other in this reaction, which, by the way, is a double replacement reaction, just so you know. This change also leads then to the actual skeleton equation, which is Na3PO4 aqueous plus CaCl aqueous, which equals out to NaCl aqueous plus Ca3PO42 solid. That's a solid. Now we have to balance the equation in order to get the proper measurements. Step 2 is going to be the hardest, which is balancing the equation. So we already have our skeleton equation, which is, as you can see, and what we need to do now is take note of how many ions or elements are in each compound on either side of the skeleton equation. And since our goal is to make everything equal, we have to add coefficients to each compound, or maybe not at all, to find whether or not we can make these compounds equal to each other. So I want you to continue reading what I've written here, because I don't feel like talking about it all. Alright, you're back. Step 3 is going to be the easiest one so far. You just got to follow 3 steps. Alright, step number 1. Start with the balanced molecular equation. We just did that, so we're done. Step 2. You got to break all soluble compounds with aqueous beside them into their separate ions. And you have to indicate the correct formula and charge of each ion, indicate the correct number of each ion, and write aqueous after each ion. So, that was a lot of ions. Step 3. You leave all compounds with the solid marking, liquid marking, or gas marking unchanged. So you got to leave all those together, and you got to bring them down with the rest of the equation. And this makes 6 Na plus aqueous plus 2 PO4 3 minus aqueous plus 3 3A2 plus aqueous plus 6 Cl minus aqueous, which equals 6 Na plus aqueous plus 6 Cl minus aqueous plus Ca3PO42 solid. There you go. Alright, moving on to step 4. Alright, our final step is to complete the net ionic equation. So our first step for this is to write the complete ionic equation, which is what our last step was. And for this one, we have to cross out any spectator ions from the giant equation that I read out earlier. So that includes the 6 Na plus aqueous on either side and the 6 Cl minus aqueous. So we gotta just take those out. They're gone. What's left is that we have to write any leftovers, which equals to 2 PO4 3 minus aqueous plus 3 Ca2 plus aqueous, which equals Ca3PO4 2 solid. And there you go. That's it. I hope you guys enjoyed this, and sad to say this is my first YouTube video and it's chemistry, but yay.